Okay, this is 4.3 part 2. The question asks us to find the domain, the intercepts, the interval in which f of x equals the cube root of x squared minus 4 squared is increasing or decreasing, any local extrema, and the end behavior. So these are the things that I need to do. So if I look at the function, first of all, the original function is f of x equals, the cube root, let's leave it in that form, of x squared minus 4 squared. And we're talking about the domain first. So the domain is what can I plug in for x. And if I plug in a positive number, I'm going to square that positive number and then square it again, and then I take the cube root of it, it's going to be a positive number. If I plug in a negative number in for x, such as, negative 5, let's say, I'll get a negative number squared, which becomes positive, and then I'm going to square it again, which becomes positive again. So it really doesn't matter what I plug in, it always becomes positive. So the domain is all real numbers. So let's go ahead and put a block around that because that's going to help us graph. And then it's going to ask us what are the intercepts. So the x-intercept, you're going to let y equal 0. So you have 0 equals x squared minus 4 raised to the 2/3 power. Now I'm going to take and multiply both sides by 3/2. So I get 0 to the 3/2 equals x squared minus 4 to the 2/3 times 3/2. I get 0 equals x squared minus 4. Solving for x, I get x minus 2, x plus 2 equals 0. X equals 2, and x equals negative 2. So the x-intercepts are 2, 0, and negative 2, 0. Now let's take care of the y-intercept. You let x equal 0. So if we plug in 0 in for x, I get 0 squared minus 4 squared. So y equals the square root of negative 4 squared. Y equals the cube root of 16. And that's approximately equal to 2.6. So that y-intercept is going to be 2.6, 0. Okay, so I have the intercepts done. I'm also going to take care of the end behavior before I do a sign chart, finding out where the function is increasing or decreasing. So if I do the end behavior, remember I'm taking the limit as x is approaching infinity of the function. So remember the function was the cube root of x squared minus 4 quantity squared. So if I plug in infinity in for that, I get infinity squared minus 4, and then I'm going to square that again and then take the cube root. I'm going to get positive infinity. So I know as x is approaching positive infinity, the y values are going to go up to positive infinity. And if I do x approaching negative infinity of the function, I plug in negative infinity in for x. I get negative infinity squared is positive infinity minus 4, and I'm going to square that. I'm going to get the same answer again. I'm going to get positive infinity. So we know that on both sides of the graph, it's going to shoot off into infinity. So the question is what's going on, for the rest of this. So what's happening in here? All right, so that's where we need to talk about is the function increasing, decreasing, etc. Okay, so to do that, first of all, I got to find the derivative, and then I'm going to set it equal to 0. So finding the derivative of the function, first of all, I'm going to go ahead and write the function out. So it is x squared minus 4 raised to the 2/3 power. And when I take the derivative of that, I bring down the 2/3. I have x squared minus 4. And then 2/3 minus 1 is going to be negative 1/3. Now I have to use the chain rule, and I have to take the derivative of x squared, which is 2x. So f prime of x is going to equal 4/3 x. And you could actually write it up like this. Let's put the 4x on top. And then 3 times the cube root of x squared minus 4. I'm just going to make sure that we know that this is a cube root. Okay, so that's what's in there. Okay, alright, so I found the derivative, and just so it's a little bit more clear, I'm going to go ahead and rewrite it as 4x over 3 times the cube root of x squared minus 4. Okay, so remember I have to set this equal to 0. If I set the numerator equal to 0, then x equals 0. If I set the denominator equal to 0, we have 3 times x squared minus 4 to the 1/3 power, and it equals 0. So if I divide both sides by 3, I get x squared minus 4 equals to the 1/3 equals 0. Multiplying both sides by 3 over 1, or 3, I get x squared minus 4 equals 0. Now I have x plus 2 times x minus 2. And I'm going to set those equal to 0. So x equals negative 2 and x equals 2. So my critical points, putting this all together, is x equals negative 2, x equals 0, and x equals 2. So those are my critical points. So when I make up my chart, remember I have to take care of these in order. So critical point equals negative 2. Critical point equals 0. Critical point equals positive 2. And I'm going to make a sign chart next. Okay, so we're going to use test points, and then I'm going to plug in the test point, and I'm going to determine if it's plus or minus. Then I'm going to state if the function is increasing or decreasing. And then finally, we're going to determine if we have any maxes or mins. So let's go ahead and find a test point. So I'm going to pick a value that's smaller than negative 2, like negative 3, for instance. And then I'm going to pick x equals 1. On the left-hand side is 0. And on the right-hand side of 0, and I'm going to make that negative 1 actually, we're going to do x equals 1. And on the right of 2, I'm going to do x equals 3. So I'm going to use these values. Remember, I have to plug them into the derivative. So I have to plug them into this formula here. And I just got to determine if it's plus or minus. Okay, so if I plug in negative 3 into that equation, I'm going to get a negative in the numerator because 4 times negative 3 is a negative. And if I plug in negative 3 into the denominator, I get negative 3 squared, which is 9 minus 4. That's a positive value. So negative divided by positive will give me a negative. So my function is decreasing. Okay, so let's go ahead and do negative 1. So if I plug in negative 1 in for x in the numerator, I get 4 times negative 1, which is a negative value. And if I plug in negative 1 into the denominator, I get negative 1 squared, which is positive 1. Minus 4 is a negative. And remember, I can take the cube root of a negative number, and that becomes negative. So a negative divided by negative will give me a positive result. So my function is increasing. If we plug in the value of 1, I get 4 times 1, which is a positive value. And if I plug in a positive 1 in the denominator, I get 1 minus 4 underneath that cube root. That's a negative. So that result in the denominator is going to be negative. So positive divided by negative, negative. Function's decreasing. And then finally, if I plug in 3, 4 times 3 is 12. That's positive. And 3 squared is 9, minus 4 is 5, so my denominator is positive as well. So positive divided by positive is a positive, increasing. So we're going to see this function go, down and up, and then down and then up. So right here, at the critical point -2, I have a minimum. Okay, at the critical point of 0, I have a max. And then at the critical point of 2, I've got a min. Okay, so if you want to find the corresponding y values for these minimum and maximums, what you're going to need to do is you're going to have to plug in the value in for x. So if I plug in, let's say, -2, if I plug in -2 into the original function, so I'm looking up here, I get -2 squared, which is 4. 4 minus 4 is 0. So the result of that is going to be 0. So your minimum is actually at -2, 0. If I plug 0 into the original equation, I get a -4 squared, which is 16. Remember, we found that already. It's 2.6, 0, 2.6. That was my y-intercept. And then my minimum, if I plug in x equals 2, once again I get 2 squared, which is 4. 4 minus 4 is 0. Cube root of 0 is 0. So this is 2, 0. So I have my points. I also have, what's going on with my function. So the next step is to actually graph it. So we're going to graph this function here. Okay, and then this is the x-intercept, the y-intercept, the x-axis and the y-axis. I'm going to go ahead and put the intercepts in, which are -2, 0, and 2, 0. Remember, those were my critical points as well. And then I'm also going to put in my y-intercept, which was 0, 2.6. Okay, and then I'm going to look at what we got. So at -2, 0, remember it's a minimum because the derivative is going to be decreasing and then increasing. So that kind of looks like this. So the derivative, if we took the derivative of this, see how it's decreasing? And then it's going to increase until I hit the next critical point. Okay, and then let's see what we have. At 2, 0, at the critical point of 0, I have a maximum. So that means the derivative is going to be positive, and then it's going to switch to negative at that point. So a positive slope would be right here, so I drew that in already. And then let me erase that really quick. And then a negative slope would be like this, right? Because my slope is negative there. Okay, all right. And then finally, at the critical point 2, 0, if we look back, we can see that it is increasing. Okay, so it's increasing there. All right, so I have the graph of this function completed, and I just wanted to show you, you can tell the domain is -infinity to positive infinity, and I also wanted to talk to you about the end behavior. As x is getting more and more negative, y is increasing. So that's what we have. And as x is getting more and more positive, y is increasing, and that's what we have. So our graph looks good. Yeah. And remember, guys, these are corners right here. Whoops, I didn't mean to do that. So these are the corners. That's why the derivative, does not exist in those places. All right, so that is example number 2. We're going to have another video, because this one's getting long, of example 3.